rate expression for this. Formation of N2, ammonia. So N2 plus H2 gives NH3. So everything is in gaseous state. 2 NH3 hoga, there will be 3 H2. So what would be the rate expression for this one?
Minus delta N2 by delta T is equal to minus 1 by 3 delta H2 by delta T is equal to 1 by 2 delta NH3 by delta T.
Yes. So this is equal to reactants में हमेशा minus होना चाहिए, and if there's a stoichiometric coefficient, need to divide. So minus 1 by 3 delta H2 by delta T, which will be equal to plus half delta NH3 by delta T. Okay. So don't forget about the coefficients, and this is how you equate it. So the rate of disappearance of any of the reactants will be equal to rate of appearance of the products. So don't forget that all of them are equal to each other. This is the expression. Okay, so we'll do one question based on this concept. Let me know once you guys are ready, then I'll display the question. You guys might have done it. So आर्या सिया कावेरी, you guys, ये पहले हो गया था ना चैप्टर, लेकिन बीच में एग्जाम्स आया था. Did you guys get to do questions from this chapter? Practice properly? नहीं? ठीक है. Did you do the question bank?
We didn't get one.
Oh, okay. Okay. Smira, finished noting?
Yes, ma'am.
Okay. So ये वाला example 2. So the decomposition of N2O5 in CCl4 at this temperature has been studied by monitoring the concentration of N2O5. So they kept track of the reactant N2O5. So initially it was this much, and after 184 minutes, it reduced to this much. So this is the rate equation, chemical equation. So calculate the average rate of this reaction. You guys don't need to do it in hours, minutes, seconds. Just do it in minutes, abhi, so that just get the hang of this thing. Hours and seconds, literally just time ko convert karna padega. You guys can do that easily. So let me cover up the answer here. So do the first part pehle. Calculate the average rate of the reaction during this time. So you're given, like when you read the question, write down everything that is given. So what all are given?
Concentration of the reactant and the time.
यहाँ पे दो reactants दिए ना, you need to be a little more specific. So time, so basically your delta T is given as 184 minutes. They measured for 184 minutes. Then what is this value, 2.33, and what is 2.08?
2.33. Ma'am, the reaction that is written below, it doesn't have CCl4 in it.
That's a catalyst, no? Decomposition of this in CCl4. So in CCl4, it is decomposing into NO2 and O2. That's more of a reaction medium or a catalyst sort of a thing. So R
In minutes, right?
just
In
calculate in minutes. You don't have to do all three. Minutes is the most direct one. Be easy. So from this delta T तो है हमारे पास. You need to calculate delta of the concentration of the reactants. Then reaction is given. There are stoichiometric coefficients. So be careful in your rate ka calculation. So I'll give you guys a minute once you finish. क्या हुआ? हो गया? How to do it? Smera is the first one to answer. Let's see. Sia 1, 2, 3, 4. Okay. Yeah. I also got the same one. Yes, both of you got it. Sahi hai. Sia, check units again properly. Yeah, numerically it's correct. You just need to check the unit. Yes. Kaveri, you won't get it in negative. इसलिए ना formula we modify it a little for reactants.
Oh yeah, sorry.
So delta R, naturally you'll get it in negative, but when you calculate the rate, it's not a negative value. That's why reactants के लिए we put that minus sign. Yeah. Okay. So Sanskriti Arya, yes, send it quickly. Close. Arya, check the number of decimal values. Numerically, kind of correct. Just the number of decimal values. You're off by a factor of 10. Sanskriti, kitna mila? Where are you at? Tell me what did you get? Oh, fraction. Okay, let's divide it and see kitna hai. 1, 2, 3. Yes, you got it. Yeah. But get comfortable with fractions, Sanskriti. Find out shortcut ways of using, like, doing calculations. How I would approach this is like, okay, since all of you numerically got it, okay. So this is 1 by 2. I'm glad no one forgot about that. 0.25 divided by 184. Right? So this you can write it as, I'm just gonna increase like 250. So 3 decimals hai na, into 10 power minus 3 by 2 into 184. Now this becomes like fairly easier for division. 250 divided by 200 and 300 and something. So 0 point kuch to aayega. Or you can even reduce it 2 times 125 times. If you add another 0, make it 10 power minus 4. Then this goes in like 4. This goes, you can further reduce this. So be better for the calculation. Be more comfortable. That's it. Okay. So iska answer you should ideally get 6 point something into 10 power minus 4. So Arya, you got 6 into 10 power minus 3. So check. Hither to like you forgot 2.5, 25 decimals somehow, somewhere. Check that part. Okay. So first part, you guys got it good, not bad. So we'll look at the second part. So पूछ रहे हैं, what is the rate of production of NO2 during this period? So how are you going to do it? So you found out the rate. So take rate as 6.7 into 10 power minus 4 mole per liter per minute. How would you calculate the rate of production of NO2? How can you equate this rate to the production of NO2 during this period? So what is the formula of rate of production of NO2? Like if you write it in terms of NO2, क्या आएगा? Rate will be equal to
1/4
yes 1/4 into the rate of production of NO2. So when it comes to rate, you need to include that time anyway. So
but how do we know the concentration?
so you don't need the concentration. What they're asking is what is the rate of production of NO2? So this value कितना है? So
Yeah, so you need the concentration for that.
no, the rate of disappearance of N2, like 1/2 into the rate of disappearance of N2O5 will be equal to 1/4 into the rate of appearance of
Yeah,
NO2.
yeah.
Yeah. So you already have this thing, which is also equal to this thing, 1/4 into the rate of appearance of NO2. So all you have to do is like multiply it by 4, you'll get it. Okay, so this is the main equation. So rate will be equal to minus half delta N2O5 upon delta T, which is also equal to 1/4 into delta NO2 upon delta T, which is equal to oxygen का कोई stoichiometric coefficient नहीं है, so delta O2 upon delta T. So this is what you like, because you only know the concentration of N2O5, so you use this to find the rate, then same
Yeah.
thing is also equal to the rate of appearance of this thing. Yeah.
So we need to find delta NO2 by delta T, right?
Yeah.
But in the rate of production of NO2, 1/4 will still be included, right? Because that's the coefficient in the reaction, right? Like we would, I mean, the whole thing would be the rate, right?
Rate of the reaction. But here we are specifically asking how, like, what is the speed of appearance of NO2 alone?
No, like NO2 there are 4 moles, right, of NO2. So that won't that also be counted in the rate, like the value that we need to find out? I mean, shouldn't it be just 6.7 to 10 raised to minus 4?
No, so that's general rate of the reaction. But like every time the reaction is happening, like every time 2 molecules of NO2 are disappearing, we're getting 4 molecules of NO2, right? So purely in terms of NO2, if we focus just NO2, they are appearing by a factor of 4, which is why, like, that's why we had
And,
divided it in the first place, right? So now it's
and had there been no stoichiometric coefficient, then it would have been the same.
yeah. Like if you're looking at it in terms of oxygen, it'll be the same as the rate. क्योंकि यहाँ पे कुछ है नहीं. Okay, cool. So Sia has calculated. Everybody else, simple multiplication, guys, like 30 seconds से ज़्यादा नहीं लेना चाहिए. So take 6.7 into 10 power minus 4 into 4. Just need to yes. Yeah. अरे अच्छा 2.3 ठीक है. Yes. Sanskriti, Arya, 14. Focus, Sanskriti, like this is how you need to avoid
Ma'am,
syllables.
I got to the typing mistake हो गया.
वही तो, you're not focusing, इसलिए वो mistake हुआ ना. And it's not even like a finger slip thing. You're just not focusing. 0 and 4 are pretty far away. Concentrate, like focus, like pay attention here. Okay. Idea also sent in. Okay. So this is kind of how you would use rate equations. Yeah, this is the basics of, okay, what is rate? How do you calculate it? You do it in terms of rate of the reactants disappearing or products forming. So next section is about factors relating to the rate of a reaction. Factors affecting the rate of reaction. What do you think would affect the rate of a reaction? Like, how do you speed up or slow down reactions?
Le Chatelier's thing.
I mean, Le Chatelier's affects equilibrium. Yeah, pushing equilibrium to the left or right. Here we are talking about speeding up or slowing down the reaction. So what all are the different factors?
Ma'am, temperature.
Temperature is one, yes.
Nature of reactants and products.
Nature of reactants and products.
Pressure.
Okay. So pressure, Arya, like pressure, I mean, if you're doing it in a solution, if it's like an ionic equation or something, pressure won't affect it so much, right? So pressure is a little more specific in that only if the reactants or products are gases. Because pressure literally affects, like if you increase the pressure on gases, volume decreases. So that in turn increases the number of collisions, like basically affects the molecules directly. But if you just have like, imagine this was not water, something else, no matter what I do to the external pressure above the liquid, like under jo bhi molecules hai, they're doing their own thing. So what is the counterpart of pressure to gases for the ones in solutions?
Vapor pressure, partial pressure.
Whatever type of pressure it is, it's for gases, right? How do you affect something that's in the liquid state?
Concentration.
Concentration, yes.
How is that pressure?
So gases may what pressure does, solution may that's what concentration does. So when you're increasing the pressure, matlab you're compressing something, you're getting the molecules closer together, so more chances of like collision. Also, another way of increasing the pressure is to increase the number of molecules itself. Like you increase N, P also increases, right? So increasing the number of molecules or bringing them closer, like concentration, you're increasing the number of molecules directly by adding more of the reactant. Or if you change, like if you affect the product, like that also will affect it somehow. So yeah, so pressure or concentration, similar thing. We'll be studying both of these like together. How else do you increase or decrease the rate of a reaction? How else do you affect the rate of a reaction? So this we're talking about when we say pressure concentration, both. So reactants mainly. Products will like push the reaction backwards, so that also will affect it. But we're not gonna worry about products right now. We'll focus on the reactants. Okay, so we have temperature, we have concentration or pressure. What else? What else do you do? Like think of all the reactions that you've come across. What are the different conditions You've come up.
Catalyst.
Catalyst is one, yes. So catalyst also affects the rate of the reaction. So catalyst. So you use catalyst in order to speed up reactions, make it easier for them to happen.
Does like promoter also affect the rate because it helps in making the catalyst work better?
Yeah. So all of that comes under the same thing. So catalyst and how catalyst is affected. So promoters, poisoners, inhibitors, similar to catalyst, but like it works in reverse. So all of that same category. Yeah. Okay. So we will be focusing mainly on pressure, pehle, and then we look at temperature and catalyst. So this you don't have it in detail, like in terms of numericals and formulas and all that. You'll be focusing mainly on the concentration of the reactants. Okay. So how do you think the rate is affected with concentration? So we're talking about concentration of reactants. So
Wait,
how
can you go to the previous one? Yes. Okay.
so if you want to increase the rate of a reaction, what do you need to do with the concentration of reactants? Like, do you increase
We'll
it?
reduce the concentration to increase the rate of the reaction, right?
Why? How does that
If there
work?
are lesser number of reactants, so then the reaction will get over faster.
No, if you increase the concentration, the Chatelier thinks that will go like forward, the reaction will go forward.
Okay. So let's
Forward doesn't mean that the rate will be
simulate.
faster or slower.
But then it will be promoted towards like right or forward.
Oof, what happened here? Let's do this. Okay. So Arya and Kaveri have given their listing. Sia, Smera, Sanskriti, what do you guys say? If I put in more amount of the reactant, am I speeding up the reaction or reducing it?
If you put more reactants, then you're increasing the rate. It will
Yes, ma'am.
facilitate forward reaction and give more products.
Okay. Smera, Sanskriti?
I also think that the speed will increase if we
I agree
increase the
with
number.
Hmm. Okay. Yeah. So Arya, 4-on-1. Let's see. So I've taken 5 and 5 of the reactants. A is 5 and BC is 5. And let it happen. कहीं पे भी time का ये नहीं है ना. Let's.
What is this like?
This is a
the
simulation, like
the
just a
reactant.
simulation. Yeah. It's a reaction ka thing. We'll see the stopwatch. We'll start with 1, 2, 3, 4, 5 molecules of A, 5 molecules of BC. And we'll increase the temperature so that we don't take like a lot of time. Let them. So start, begin experiment. So okay, यहाँ पे कितना टाइम लगा? So 409, around 410, 415 tak. How many molecules of the products are formed? How many of AB do we have here? Oh, nothing is formed.
Very slow reaction.
Yeah. Let's make it hotter. Then begin again. So we'll let it go up to like 400-500 units.
Did this you increase temperature or concentration?
Temperature अभी के लिए. Okay, so 458 तक जाने दिया, and you can see that 2 molecules of AB and 2 molecules of C have formed when I started with 5. Okay, so someone like make a note somewhere so that we can compare. So
Molecules of AB are
So I started with 5 and 5 of each, 5A and 5BC. So at 458, 2 molecules of each is what I got. Okay. So reset stopwatch. Let me increase.
what is the gray thing? C.
Gray.
Where did C come from now? You had initially you had A.
So
Oh,
A and
plus
BC.
B. Okay.
So this is the reaction. A plus BC gives AB plus C. So now I've increased it to 10 and 10. Okay. So let's see what happens. Same temperature, conditions change nahi kiya. So start, begin. So already at like hundreds only, like considerable increase here, see. Let it go till 450. I'll aim at 450. See. Thoda sa gaya. But yeah, so we could see how quickly the product formation has increased. Like right during hundreds itself, we could see that it has increased. Right, same temperature, same reactant, same products. The only thing we changed was the number of molecules that we started off with. Okay, so concentration increases the rate of the reaction. And theoretically, if you want to reason it out, actually we'll discuss the the reason or how the reactions happen. So there's something called collision theory of reactions. So reactions will happen, like if you want a chemical reaction to take place, you need the individual reactant molecules to collide against each other. So if they don't meet, then the new bond formation will not happen. Okay.
Wait, this has nothing to do with Le Chatelier's?
Le Chatelier's is a consequence of it. Like this we're talking about is how reactions take place. Like what is the basis for reactions to take place? Koi bhi reaction ho, if you keep them in two separate beakers, nothing's gonna happen. You need the molecules to physically collide against each other. Only then can bonds break and new bonds form. Otherwise, they'll be chilling, minding their own business. So when you're increasing the concentration of the reactants, you're literally increasing the number of molecules. So when you're flooding this with, all the molecules of the reactants, you're literally increasing the chance for collision to take place. So that's how the rate of the reaction is also increasing accordingly. Now, it's not always the same. It's not always uniform, which is what we're going to see in this particular section. The rate of reaction, it is directly proportional. But again, as Smira said, nature of reactants, nature of products does matter. So for different reactions, you're going to have a different factor by which the concentration is going to affect. And you do have reactions where the concentration of reactants does not matter at all. So those also exist. So these are the cases we'll be looking at in all of these sections. So in general, most of the cases, so if we, so from the variation, okay, let's stop. So rate is
One
directly
second.
proportional. Sorry.
In the list that you gave, Smith, the second one you've written pressure, oblique concentration. So how are they the same thing? I don't understand.
So if you're looking at a gaseous reaction, like reaction in which the products reactants are gases, you can measure it in terms of their partial pressures. But if it's a reaction where it's taking place in solution, in like aqueous form,
Oh.
solid liquid, you talk about it in terms of concentration. So rate is directly proportional to the concentration of reactants. But by how much does this factor vary is going to change from reactant to, it depends on the reaction basically, what is forming and what is taking part in this. So in general, if you have a reaction AA plus BB gives rise to C plus D. Is this familiar to you guys? Starting to look familiar, sort of equations and all. Yeah. So the rate of a reaction is directly proportional to the concentration of reactants. So we call it as A raised to the power X and B raised to the power Y. So X and Y are, sometimes if you double a reactant, the rate of the reaction may get squared, it may become cubed. Like that's what the X and Y represent. It's not always a linear relationship. So X and Y vary from reaction to reaction. That's the thing. The only way you can figure out by how much this changes is experimentally. Yeah. So you cannot predict it, and it's not always equal to the stoichiometric coefficient. Sometimes it is like it's a happy coincidence where it's a direct relation, but not all the times. You can't theoretically deduce ki kitna hoga this factor. It's only experimentally determined. Okay. So if you want to convert it into an equality, so rate will be equal to introduce constant of proportionality, A raised to the power X, concentration of B raised to the power Y. And this expression is called the rate law. So every reaction has its own rate law. It is a property of the reaction. You also call it rate expression. Okay. Yeah. So when you substitute the value of rate, like since we are focusing on the reactants, so minus dr by dt. So reactant, you can choose any one, either in terms of A or in terms of B. Like we saw that all of that will be equal. Take into account the stoichiometric coefficient and all. So this will be equal to K into concentration of A power X, concentration of B power Y. And when it is written in this form, this is called the differential rate equation. Okay. So depending on X and Y का क्या values है, the integrated forms will vary. So after integration,